Okay, so we're going to start by looking at the Trigonometric Identities reference chart. We are not looking at all of this stuff today, okay, but it is all in one spot because eventually we will get there. And the ones that we work on today will also be on the notes, but again, it's good to have just like a separate thing to be able to look at and make sure that you can actually find what you need on here and can use this correctly. Do you have to memorize all of these? No, you do not. But you have to be able to use this sheet. I mean, just because you have a chart doesn't mean you know how to find the stuff or that you know what to do with it. So make sure you're familiar with this. Some of this stuff, you don't have to memorize it, but you already know some of it, whether you have tried to memorize it or not. And there will be a couple of these that come up in calculus that you use over and over again. And I don't really consider that a memorization thing. That's more of you're going to use it so much you're just going to know it kind of thing. So, but no, you're not going to have to like go make flashcards or anything. The ones that you already know are the reciprocal identities. You've known those for a while since we started talking about trig stuff. Because this just says sine is 1 over cosecant, cosecant's 1 over sine. So you already know that, right? You know all of those, no big deal. You for sure know that tangent theta is sine over cosine. I honestly don't recall if we actually talked about cotangent this way, but if cotangent's the reciprocal of tangent, then it stands to reason that it would be cosine over sine. Okay, does that make sense? So that whole first row, you already know them. So you don't have to memorize them because you already know them. We're also going to look at the Pythagorean identities, the cofunction, and the even and odd identities today, which will be new to you. Okay, so keep this handy. If that means it's open in another tab for you to be able to flip back and forth, that's good, or whatever else works for you. And then let's see what we're going to do with these, what a trig identity even is. Okay, so a trigonometric identity is an equation, that means there has to be an equal sign, involving trigonometric functions that is true for all values for which every expression in the equation is defined. Okay, so basically, it's a true statement about the relationship between whatever it is in our equation, and then we're going to use these things to manipulate what we have to get it into the different forms that we need. So the identities help us evaluate functions, simplify expressions, verify identities, and solve equations. So we're going to start off small, manipulating some stuff, because you basically have to understand how that works and practice with that in order to use this for what you really, really use it for, which is like solving equations and simplifying stuff that you're trying to do, okay? All right, so again, here are your quotient and reciprocal identities. All this being true, and the denominator can't be 0. All that stuff is kind of a no-brainer. And our directions, as you go through this stuff, make sure you're reading the directions and doing it in the way that it says. So it says to use the quotient and reciprocal identities to find each value. So those are the only ones we know right now anyway, so it's really our only choice. So if we look at this, I have secant theta, right? It's equal to negative square root of 30 over 3, and I want to find cosine. All right, so how are secant and cosine related to each other in general? They're reciprocals of each other. Okay, so they're reciprocals of each other. So I know that secant is the reciprocal of cosine and vice versa. So if I have secant, then I know that the cosine of theta has to be the reciprocal of secant, so that means it's negative 3 over the square root of 30. So that value is correct, but the form is wrong. Why? Square root in the denominator. Right, so I need to rationalize. So I'll get negative 3 square root of 30 over 30. Then I can reduce. Can I reduce by canceling the 30s out? No, but I can reduce the 3 and the 30, so this would be negative square root of 30 over 10. And that is the cosine of theta. Okay, so we're just using what we have, manipulating it to get what we need. Okay, we good with that? All right. So number 2, we have, they give us tangent, they give us cosine, we want to find sine. So there's no reciprocals of each other in there, but I do know that the tangent, and they're using x here, I do know that the tangent of x is equal to sine of x over cosine x. So I can just set that up. So I substitute in what I know. I know the tangent value, it's the square root of 2 over 4. That's equal to, I don't know sine, so it goes in there as sine, over, and then I do know the cosine, it's negative 2 square root of 2 over 3. Okay. So then I need the sine value. So in order to get the sine value by itself, would I multiply both sides by the denominator as it is, or the reciprocal? Okay, so don't let things confuse you, because there's square roots and fractions and trig. If I have 5 equals x over 2, would you multiply both sides by 2 or by 1/2? By 2. Kind of a no-brainer, right? Because you're just multiplying by the denominator. So I'm just multiplying by the denominator as it is. And I'm asking you this that way because that's a mistake I see a lot on this. You're not using the reciprocals in the right form. I just multiply by the denominator. So this is the square root of 2 over 4 times negative 2 square root of 2 over 3. And that's equal to the sine of x. Okay. So when I multiply, I can go ahead and reduce before I multiply. This 2 can cancel with this 4 to make that become a 2, right? And then what's the square root of 2 times the square root of 2? 2. So then those 2's also cancel out with that one. So now that's all gone. So all I have is that the sine of x equals negative 1/3. Any questions about where anything came from or what anything is? Are we all good? Okay. So let's look at number 3. They give me the cosecant and the cotangent, and I want the secant. Well, none of that stuff is reciprocals of each other, nor do they just go straight into a fraction like this. However, just like when we were thinking about our unit circle values, sometimes it helps to take the reciprocals and make them back into sine, cosine, and tangent. Because what I do know, I have cotangent right here. And I do know that the cotangent of beta would be equal to the cosine of beta over the sine of beta. Does that make sense? So if I could take this right here, and instead of it being cosecant, I'm going to make that into sine. So sine of beta would be 3 over 7. Catch my logic here? So now I can use the cotangent and the sine. That will give me cosine, which is not what I'm looking for, but once I have cosine, will I be able to get secant? Yes. Okay, so I'm going to substitute this stuff in. And let's see, my cotangent is negative 2 square root of 10 over 3. That's equal to the cosine, which I don't know, over the sine, which is 3/7. Then, okay, so then I'm going to multiply both sides by 3/7. So I get negative 2 square root of 10 over 3 times 3 over 7. And that's equal to the cosine of beta. So these 3's cancel out, and I get that the cosine of beta equals negative 2 square root of 10 over 7. Am I done? No. In Confessions of a Bad Teacher, second period, I boxed this and I was like, oh, any questions? And then I went, oh, yeah, why didn't I finish the question, right? I didn't answer what I got an answer, but that's not what I was asked for. Asked for secant. That's cosine, which means the secant of beta is going to equal negative 7 over 2 square root of 10. So when I rationalize, I don't have to multiply by 2 square root of 10. Just the square root of 10 is enough, whatever the square root is. Which means that would give me negative 7 square root of 10 over 20. And that is the secant of beta. What questions do you have? Anything? Okay. All right, then let's look at our Pythagorean identities. We are going to start by drawing a triangle that's in the unit circle. Okay, now I'm not drawing a circle because it won't look like a circle and it'll take away, but pretend like there's a circle around here, right? And this is just a triangle that we would have drawn in the unit circle. This is theta. If it's the unit circle, my radius is 1. And all of those points around the unit circle, the x value was cosine theta, y value was sine theta. Okay. So we did a problem a couple days ago where I could give you the cosine value, and then you'd have to draw a triangle, do the Pythagorean theorem, get a value, then you could give me the sine value. Well, we don't have to do all of that because we have these Pythagorean identities, okay, that say, if I did do this, first of all, if I use Pythagorean theorem here, it's cosine squared plus sine squared equals 1. Make sense? When you do this, when I take cosine theta and I square it, you actually write it as cosine squared theta. So you'll never see it this way, and we don't write it this way, but this is what this means. Okay, you're squaring the value. You're not squaring the angle or anything else. So that's why it's cosine squared theta plus sine squared theta equals 1. That's your Pythagorean identity. Okay, does that make sense to you? So the other two actually come from this, and we could force it back into that. So if we looked at it this way, if we look at this one, I'm going to rewrite this one. So it starts with tangent squared. If that's tangent squared, then I could make it into sine squared theta over cosine squared theta, right? Since tangent is sine over cosine, tangent squared is sine squared over cosine squared. So that's the tangent squared theta. Then I could do plus 1 equals, and instead of secant squared theta, I could put 1 over cosine squared theta. Okay. So first, make sure you're with me that all I did was rewrite tangent squared and secant squared, and this is what I ended up with. We okay with that? Tangent squared is sine squared over cosine squared, secant squared, 1 over cosine squared. So now if I took that equation, and I'm not going to because we don't have to write all this down. If I multiplied through by cosine squared, this one would cancel out. I'd be left with sine squared. I'd get a cosine squared here, and I'd get a 1 here, and I'm right back at this one. Okay? So they're just different forms of those. If I multiplied through by cosine squared, then it would all cancel out, and you're right back there. Okay? You don't see it? Okay, it's okay. I can tell by the look on your face. That's why, do I need to say it differently? Anybody else? I appreciate those facial expressions sometimes, though, because sometimes when I get blank stares, I don't know if you get it or not. When you look at me like I'm crazy, I know there's an issue. So, are we good? Okay. Okay. So that's where these come from. Now, this one, should you just know this one because it's a squared plus b? Yes. I mean, this one we shouldn't have to look up. These two, because you're trying to figure out which one's on the inside and outside or whatever, maybe. But eventually you'll kind of just know how that works as well, all right? Okay, so now what we're told, use the Pythagorean identities to find each function value. So I want to find cosine and tangent if sine theta is negative 1/3 and cotangent is less than 0. Before I jump in and start doing anything, I have to think about my quadrants. Okay, this is the part that gets skipped a lot, and you can't skip this. So what I mean by that is this. So I'm going to draw my little 4 quadrants here. They're telling me that sine is negative 1/3. Which quadrants is sine negative in? The 4th and the 3rd. Okay, it's 2 quadrants that it's negative in. Okay, 3rd and 4th. Then they're also telling me that cotangent is less than 0, which means tangent is also negative. Which quadrants is tangent negative in? 2nd and the 4th, right? Make sense? So now I look to see where they overlap. Like you literally need to make these dots. If you try and keep it in your head, you're going to mess something up at some point. So they overlap here. This is where sine and tangent are both negative. That means my answer has to be in the 4th quadrant. That's a very important part of how you answer this. And you need to start with it so you don't forget to use it. Okay, so now we know we're going to be in the 4th quadrant. So I'm going to go and look. Let's see. I want to find cosine, and I have sine, so I can use this. Because I'm looking for cosine. I have sine. That'll be my only unknown. So this will be cosine squared theta plus negative 1/3 squared equals 1. So cosine squared theta plus 1/9 equals 1. So now I have to subtract 1/9 from both sides. What would that leave me with? Eight ninths. No, you're right. 8/9. Now, that's cosine squared. I don't care about cosine squared. I want cosine, so I take the square root. And that gives me cosine of theta equals plus or minus the square root of 8/9. That is the same thing as the square root of 8 over the square root of 9, but I'm not going to write that step because I don't really need to. So to simplify, this is going to give me plus or minus. The numerator is 2 square root of 2 over the denominator, which is 3. So that's what you get for cosine, except that I have to take into account that sine is negative and cotangent's negative. I'm in the fourth quadrant, so in the fourth quadrant, is cosine positive or negative? Positive. So my actual answer is that the cosine of theta equals 2 square root of 2 over 3. Any questions at this point? Okay. So then I'm going to look at, I also need to find tangent of theta. So when I look up here, I've got tangent goes with secant. Well, I don't have secant, but secant's the reciprocal of cosine. And I've got cosine, so I'm good. All right. I don't even really care about secant. I want secant squared. What is cosine squared? It's right there. I don't have to take my square roots and re-square it. I know what cosine squared is. Does that make sense to you? So then that tells me that secant squared is 9 over 8. If you can't usually read your own work and you can't follow what you did, you're not going to be able to go back and find stuff like that. Okay? That's why we've tried to train you for your whole entire math life to do those kinds of things. All right, so I've got that. Now I can substitute it in here. So I get tangent squared, which is what I'm looking for, plus 1 equals secant squared, which is 9/8. I don't have to square anything. I know what secant squared is, and it's 9/8. So pay attention so you're not squaring when you don't need to be or not squaring when you do need to be. I subtract 1 from both sides. And what am I left with on the right-hand side? 1/8, exactly. Okay, so I take the square root of both sides, and I'll get the tangent of theta equals plus or minus the square root of 1/8, which gives you plus or minus 1 over 2 square roots of 2. I rationalize, and it'll give me plus or minus the square root of 2 over 4. But then I have to look, because both of those are not my answer. I'm in quadrant 4, so will it be plus or will it be minus? Minus, because it's tangent. So tangent theta equals negative square root of 2 over 4. What questions do you have? It's imperative that you keep up with your own work, that you can follow your own work and go back and use pieces along the way. Okay. So look at number 5. I'm going to give you a little bit. I want you to see if you can figure out which quadrant you think it's going to be in. Okay, try and figure the quadrants out, and then I'll talk you through the quadrants. Okay, so here's my quadrant thought process. Let's see, I want to find tangent and sine. So secant is positive. That secant is cosine. So cosine is positive in the first quadrant and in the fourth quadrant. And then sine is also greater than 0, so it's positive, and it's positive in the first quadrant and the second quadrant, which means this is a quadrant 1 situation, and everything's positive in quadrant 1, so I don't have to think too hard. Everybody good so far? All right, so I want to find tangent, and I have secant, so that's good because that fits right in here. I can use this right here. So that'll give me tangent squared x plus 1 equals 6/5 squared. All right, so that gives me tangent squared x plus 1 equals 36/25. I'm going to subtract 1 from both sides. What does that leave me with on the right-hand side? Very good, 11/25. So then I take the square root, and I'm going to get the tangent of x equals plus or minus the square root of 11/25, which gives me plus or minus the square root of 11/5. So that's what I get when I simplify it. Then I have to give the answer that's specific to this problem, and since I'm in quadrant 1, tangent of x has to be positive, and so that's the square root of 11/5. Okay. Any questions at this point? Okay, so I found tangent. I now need to find sine. Well, secant's all they gave me. I already used the Pythagorean identity that had secant in it. Sine is only in one of those, and that's with cosine. So the good thing is that secant's the reciprocal of cosine. So if the secant of x is 6/5, then the cosine of x is 5/6. And I can use that. So then I use that first Pythagorean identity that says cosine squared, so 5/6 squared, plus sine squared equals 1. So then I square this, and I'm going to get 25/36 plus sine squared x equals 1. I subtract 25/36 from both sides, and that'll give me sine squared x equals what? Hmm? 11/36. So that means that the sine of x equals plus or minus the square root of 11/36, which is plus or minus the square root of 11/6. Since we are in quadrant 1, everything is positive, so the sine of x is equal to the square root of 11/6. Okay. What questions do you have? Anything? Okay, so then let's look at the cofunction and even and odd identities. All right, so your cofunction identities, the best way to explain these, I think, is that if I know that the cosine of pi 6 is the same as the sine of pi thirds. Does that make sense? Because they're, and those angles in a right triangle, they are complementary. So they are cofunction identities. So again, the cosine of 60 is the same as the sine of 30, and pi halves is like 90, right? So the sine of 60 is equal to 90 minus 60, which would be the cosine of 30. So that's why they're the cofunction identities. They kind of switch places. That's what that means. Do you have to memorize all of those? No, you do not. But you have to be able to pick them off the chart correctly, which is harder than it seems sometimes, and use them in the right way. Even and odd identities. So to talk about those, we're going to do a little example over here. Let's say that theta equals pi sixths. Okay? So the first thing that we're going to find is we're going to find the sine of negative theta. So if theta is pi sixths, then this is the sine of negative pi sixths, and that would be negative what? 1/2. tab. Are you with me? Then I want to find negative sine of theta. So that means I'm going to find sine of theta and then just make it negative. So sine of pi 6 is 1/2. I make it negative. I get negative 1/2 for that as well. So these two have the same value. Here's what did not happen, and I cannot stress that enough. We did not factor this negative out in the front of here, because that makes no sense. You can't factor it out like that. It's like saying the sine of 2x equals 2 times the sine of x, and they're not the same thing. So this is not a factoring situation. Because if I do cosine, so if I find cosine of negative theta, okay, so cosine of negative pi 6, that puts me in the fourth quadrant. Cosine's positive in the fourth quadrant, so it would be a positive square root of 3 over 2. If I find a negative cosine of theta, that means I would just find the cosine of pi 6, which is square root of 3 over 2. Then I would make it negative, so it's negative square root of 3 over 2. So what I want you to notice right here is that I did the same thing for sine as I did for cosine. For sine, I got the same answer both times. For cosine, I did not. Because again, we're not just factoring the negative out and making it the same value. So when you look right here, and you can reason through this as far as what quadrants they're in and that kind of stuff, but use this. Do not assume that you know, because you don't. This is all brand new to you, and it's going to be really easy to get some of this stuff confused. That's why you have this reference chart, okay? Does that make sense? Does that help some? Okay. So let's look at what this is. Now, and if you've been, some of y'all have beautiful work. You keep up with your stuff, and I'm not talking good handwriting, because some of y'all have terrible handwriting, but your work is good. Like you can keep up with your stuff. I can follow what you're doing, all that kind of stuff. But if you're used to not writing everything down, you only write half the equation, and you do this and that and put it all back in, you're going to be so lost and confused on this stuff, and this is the easy stuff. Okay, so you have got, that's why we've been trying to train you, like I said, for your entire math career since kindergarten, but some of y'all have been very resistant. So I'm going to start by rewriting what's here so that kind of all the work goes together. So I'm going to write down that I've got sine of negative theta, and that's equal to negative 0.97. So what I want is the cosine of pi halves minus theta. So you have to know your reference chart well enough to know that kind of looks like something that's on my reference chart, and I think I can find it. And so we go and find it. I'm going to find it here instead of the reference chart. Cosine of pi halves minus theta is right here. So I know that this is equal to sine. So if I have sine, it's the same thing. I'm good. I don't have sine. I have sine of negative theta instead of sine of theta. So I got to figure out how to get to sine of theta. That's when I look here. And sine of negative theta equals negative sine of theta, so I'm going to substitute that in right here. So negative sine of theta equals negative 0.97. I rewrote the whole thing, and my hand didn't fall off, okay? So, sorry, let me let her back in. Okay, so now that I'm here, I still don't have sine of theta like I want. I have negative sine of theta. So I'm going to multiply through by a negative 1, and this is going to give me sine theta equals positive 0.97. So now that I have this, sine of theta is right here, and I can substitute that in where sine is, so that gives me cosine of pi halves minus theta equals 0.97. And this looks identical to this. That's what I'm looking for. I'm done. Okay, so we used multiple representations of the angles to be able to get us there. Calculator ain't doing it for you, because we don't know what theta is and we don't care. Questions on that? They're like little puzzles. And the puzzles are actually going to get kind of fun once we start proving identities. You'll like it if you're willing to think. Okay, so now let's look at number 7. I have tangent of negative alpha equals negative 2.36, and I want to find cotangent of alpha minus pi halves. So I think that kind of looks like something that I just did that I know is on my chart. So I'm going to go back up here. I'm going to find cotangent. And besides the fact that this is alpha and this is theta, what else is different about these? They're flipped. Okay, so they're flipped. It's not exact, but I feel like they're similar enough that if I could get here, I could probably get there. So I want to get here. In order to get here, I have to find tangent. I don't have tangent, I have tangent of negative alpha, but I feel like I have a plan. That make sense? I'm going to take my tangent of negative alpha. I find it right here. That gives me negative tangent. So that means, I'm going to rewrite what's right here just so all the work follows. So tangent of negative alpha equals negative 2.36. Okay, so for tangent of negative alpha, I'm substituting negative tangent of alpha. That's equal to negative 2.36. So just like before, I don't want negative tangent of alpha, I want tangent of alpha. So I'm going to multiply through by negative 1, and I'm going to get tangent of alpha equals 2.36. So now I get to substitute. For tangent of alpha, I'm going to substitute this right here, but making it alpha. So that's going to give me cotangent of pi halves minus alpha equals 2.36. But the problem is that doesn't look exactly like what I wanted because it's backwards, so I'm definitely not done. So I'm going to go ahead and flip those around, and I'm going to get the cotangent of, this is negative alpha plus pi halves, watch your signs, that's equal to 2.36. Everybody with me so far? Stop me if you have a question. Okay, so what I can do is basically what we did when we were graphing is I can factor something out of that parentheses. I'm not factoring it all the way out to the front, I'm just factoring in here. So I can make this the cotangent of, factor out the negative, and that leaves me with alpha minus pi halves equals 2.36. We all okay with what I did right there? So this right here, whatever alpha minus pi halves is, it represents some angle, okay? And I could call that angle theta, right? And if I did, then this would be cotangent of negative theta, whatever that is. So I can look right here, and I know that cotangent of negative theta is equal to negative cotangent of theta. So that makes this negative cotangent of alpha minus pi halves, and that's equal to 2.36. Everybody follow everything? Okay, so I'm almost there, almost. This is in the right order as this now, it's just negative, so when I multiply through by a negative, this is going to give me the cotangent of alpha minus pi halves equals negative 2.36. What questions do you have? Anything at all? You're probably going to have to think a little harder on some of these than what some of y'all are used to. All right, so let's look at number 8. Number 8, the secant of beta minus pi halves. Well, it's backwards again, but so in order for me to be able to use that right here, I'm going to have to get this flipped around the right way so that I can then start to substitute. So let's work on that first. So again, I'm going to just rewrite what's here. The secant of beta minus pi halves equals negative 3.62. So in here, I'm going to flip them around. So the secant of negative pi halves plus beta equals negative 3.62. So then I'm going to factor out inside there secant of negative and then pi halves minus beta equals negative 3.62. So remember, this pi halves minus beta, this is just some angle measure. So this is like secant of negative theta. So when I look up here, secant of negative theta equals secant theta. So that means I just get secant of pi halves minus beta equals negative 3.62. Do you see how this one worked differently than this one? because we're not factoring it out to the front because that doesn't make any sense. All right, so now that I'm here, now I have something that actually matches up there. So when I come back up here, and I find this, so secant of pi halves minus beta, that's this right here. That's equal to cosecant. So I can substitute, and I can get cosecant of beta equals negative 3.62. I don't want cosecant of beta. I want cosecant of negative beta. So I'll go back up here. Cosecant of negative beta would be negative cosecant. I don't have a negative cosecant. I have a positive, so I got to multiply through by a negative 1. So we get negative cosecant beta equals 3.62. Then I can substitute again and get cosecant of negative beta, oh my goodness, equals 3.62. The bell rang on me. Any questions? No, I multiplied through by a negative. See, I was here. I needed this, so I multiplied both sides by a negative. It made that positive. All right, y'all we didn't have time for my lecture because I forgot that class was shorter. Y'all be careful on Monday.